Alright, so let's go back to question 6 that I didn't finish last time. The x-intercept of this graph, so let's work that out. So if we have this, we know that the x-intercepts are when y equals 0, so we put into 0 in the equation, 2 outside of x plus 5 squared minus 18. When we've got this, we need to solve this algebraically to find the x, so we add 18 to both sides. 18 equals 2x plus 5 squared. Divide both sides by 2, and we now have 9 equals x plus 5 squared. Now, because this is squared, we need to find the square root of both sides. So the square root of 9 is plus or minus 3, because we know that plus 3 squared is 9, but also minus 3 squared is 9. And we have x plus 5, because the square root of x plus 5 squared is x plus 5. So we can actually divide our equation into two parts. So let's start with plus 3 equals x plus 5, and then later we'll look at or when we've got minus 3 equals x plus 5. So we minus 5 from both sides, so minus 2 equals x. So this is one of our points when minus 2 and y equals 0. And over here, if we've got minus 3 here, we minus 5 from both sides, and so now we have minus 8 equals x. So we have the point minus 8, 0. So when we draw our graph, and we're looking for the x-intercepts, we've got this point here, which is minus 2, 0, and we've got this point here, which is minus 8, 0. So that's the answer to that question. That was, no, not this question here, D. Alright, so turning over, now we've moved on to other sorts of graphs. So when we look at this graph, we know that this graph is in the form of something over x. Because it's in the positive quadrant, it's going to be, and because it also passes through the point 1, 4. So if we substitute x is 1, y is 4, where do we get it true? We get it true in here. 1, 4, 4 over 1 is 4, so E is our correct answer. You just need to know that shape of those graphs. So now we're looking at this circle, and if we've got this circle here, and what does this do to it? Just like in parabolas, if we have plus 3, to make this 0, we need a minus 3, so this actually moves it on the y-axis, it moves it minus 3. So it moves it down, translates it down 3 units. You'll need to know how to move all of these things. Okay, so let's sketch these graphs. So this graph here, we know that it's a normal parabola. We know from this minus that it is going to be upside down, and we know from this plus 4 that it's going to be moved up 4. So it's going to pass through this point here at plus 4. So this is the point where x is 0, y is 4, and it's a downward one. This only asks for turning point and y-intercept. There's my y-intercept, which is also my turning point. Second question, looking at this, we know in this form that, looking at that number, we're going to have minus 1 as our x-coordinate of our turning point, and this is going to be our y-coordinate, minus 3. It's positive, so we know it's an up the right way one, and this is our turning point, so minus 1, 1, 2, 3, minus 3, so this point here, minus 1, minus 3 is our turning point, and it goes up in here. Now we need to know what our y-intercept is. Our y-intercept is when x is 0, so if we put x is 0 into our equation, y equals 0 plus 1 squared minus 3, and we solve that. 1 squared is 1, minus 3 is minus 2, So that means that it's going to pass through our y-axis at this point here, 0, -2. So that's the second point that we need to know. Oh, that's not a very good graph, but as long as I've got those points marked, you'll be marked fine. Okay, third graph here. Sketch this graph here to determine the coordinates using points of symmetry. So let's look at this and let's put it into a factorized form. And this I'm going to have to use different perfect square. So here we know that we don't have two numbers that multiply. Yes, we do. We can do that without doing this. So two numbers that multiply to be -5 and add to be +4. Multiply to be -5 is going to be 5 and 1. Add to be 4, if I make that +5 and -1, that works. So now I know that I've actually got my x-intercepts. So it's going to x-intercept is going to be -5 and +1. So I'm going to be here at +1 and 1, 2, 3, 4, 5, -5. I know now that the axis of symmetry is going to be halfway between those two. So if I go -5 -1 divided by 2 equals -6 over 2, which equals -3. So that's going to be my axis of symmetry. 1, 2, 3. Sorry, that should be plus. Yeah, -5 +1 -6 -3. Sorry, that should be +1, sorry, which is -4, which is -2, -2 over 2 is, no, it's just -2. So that's this point here. That's my axis of symmetry. Sorry, I made a mistake in here. What I'm looking for is halfway between the -5 and the 1, and that's this point here, -2. So to work out how far down my turning point is, if I put that -2 as our x-coordinate into my equation, or put into this equation, y equals -2 to this equation, +5 -1, -2 plus 5 is 3, and that's times -2, which is -6. That's where we're going to be down here. 1, 2, 3, 4, 5, 6. So this is the point, -2, -6, and that's my turning point. And I can work out what my x-intercept's here. I can work out my y-intercept. The y-intercept is when x equals 0. So I've got, same equation, 0 plus 5, 0 minus 1 is 5 times -1, which is -5. So that gives me my y-intercept. So that's this point here, which is 0 minus 5. There's my, oh, not a very good graph, but that tells me my three important points. My turning point, my y-intercept, and my x-intercepts. And one last question. No, two last. Okay, I'll stop this and start for a new video.